It is 10 now, right?
Yeah, I think Joyita, you should start. Yeah.
On behalf of the Department of Physics, Scottish Church College, I welcome you all to the 10th Professor J.C. Bhattacharya Memorial Lecture organized jointly by former Students Association of Physics and Department of Physics, Scottish Church College. I request our principal, Madam Dr. Madhumanjari Mondol, to inaugurate this program. I also request other participants to please mute themselves during the program.
Thank you, Joyita. Good morning, everybody. And this is the 10th Professor Jagadish Chandra Bhattacharya Memorial Lecture. And the topic is very interesting. Masks Unmasked. All about N95 and surgical masks, filtration efficiency, use and reuse. Dr. Arnab Bhattacharya, Center Director, Homi Bhaba Center for Science Education and Department of Condensed Matter, Physics and Material Science, Tata Institute of Fundamental Research. To you, sir, on behalf of Scottish Church College, I welcome you in our college today. I'm really grateful to Physics Department and the eminent former students of the department who have organized this webinar for all of us today. I would like to congratulate the Department of Physics on this note. In the scenario of COVID pandemic situation, the most important thing we are using are the masks. There are many types of masks which are available in the market, and it is a fact that we are really confused that which sort of mask we really want to use. For how many days we can use that mask, and whether the printed cotton masks are really effective or not. I hope after listening to our respected speaker today, we will be able to take a definite decision. Today, we have gathered here in memory of Professor Jagadish Chandra Bhattacharya, who is famous for his discovery and who actually discovered the presence of atmosphere surrounding one of the Jupiter's satellites and the ring around Uranus. But most importantly, he did his graduation in physics from Scottish Church College in 1949. On this occasion, I would like to pay my homage towards the memory of Professor Jagadish Chandra Bhattacharya, and I pray to God for his blessings on this event. I hope in coming years also, we may be able to continue this sort of event. I want to request the head of the department, Joyita, that please take the initiative from your behalf to upload all these sort of very valuable lectures in our Scottish Church YouTube channel. Again, I wish all the best to the Department of Physics and the Alumni Association for organizing this webinar. Thank you. Namaskar.
Thank you so much, madam. Now I request our Vice Principal, sir, Dr. Supratim Das, to say a few words.
A very good morning. Really, I very eagerly look forward to hearing from Dr. Bhattacharya, because as the principal already noted, the very caption is so intriguing, so interesting. I hope that Dr. Bhattacharya in the coming session is going to unmask the masks, and he is going to tell us all about different kinds of masks. Now, in the last 2 years, we have been used to wearing masks. It has become a part of our culture. And as a very obedient learner, I have always tried to wear masks whenever I am outside home or in crowded places. But I know that there are anti-masker contingents more in Europe and America than in our countries like Asia. And I know a lot of people, quite scholarly people, who used to say that, are we not right when we say that masks have become more of a facial accessory than a safety requirement? I do not know wherein lies the truth. But I always wear masks. And at the same time, I would like to add, as a social scientist, that one thing is very clear in the last 2 years or nearly 2 years, that masks have become a very potent agent of or agency of big business, crony capitalism, and all sorts of people ranging from footpath, what should I say, peddlers, to multinationals. They are now engaged in manufacturing masks. So mask is part of crony capitalism today, global capitalism today. And I would just add one more comment, that today we know that our earth is not so good earth today. 100 to 150 tycoons, business tycoons, they actually control our earth. They actually control what we call good earth. So once again, I congratulate the physics department, and I most cordially welcome our speaker, Dr. Arnab Bhattacharya, and really I eagerly look forward to what he says. Thank you.
Thank you, sir. I request Dr. Sudeb Bhattacharya, President of Former Students Association, Scottish Church, Former Students Association of Physics, Scottish Church College, to say a few words.
Thank you, Joyita. Dear Professor Madhumanjari Mandal, Principal, Scottish Church College, Professor Supratim Das, Vice Principal, Scottish Church College, Professor Arnab Bhattacharya, Dr. Joyita Chaudhary, Department of Physics, Scottish Church College, Dr. Pradipta Mondal, Secretary, Physics Alumni Association, and other participants of this virtual meeting. Good morning, everyone. As you are all aware, we have assembled here on the occasion of the 10th Jagadish Chandra Bhattacharya Memorial Lecture, being organized by Former Students Association of Physics in collaboration with the Department of Physics of Scottish Church College. Today's speaker is Professor Arnab Bhattacharya, Center Director, Homi Center for Science and Education, and also a faculty member of the Department of Condensed Matter Physics and Material Science, TIFR Bombay. On behalf of the association, I welcome you all, and also let me take this opportunity on behalf of the association and personally to wish you all a very warm greetings for this festival season. Keeping in view this significantly large number of young participants that I noticed in the list of attendance of today's program, who may not be fully aware of the work and contribution of late Professor JCB, I feel it will be appropriate at the beginning to say very few introductory remarks about late Professor Bhattacharya. Professor Bhattacharya did his, as has already been pointed out by the principal, Professor Bhattacharya did his graduation in physics from this college and received his degree in 1949. After graduation, he joined the Department of Radio Physics and Electronics of Calcutta University and gradually shifted to the field of experimental astrophysics research. He not only made very significant contribution in astronomy and astrophysics research, but also paved the way for building up a very strong research base in this field in India. In the process, he built institutions, state-of-the-art instrumentation centers, trained a bright new generation of astronomers in India, which subsequently led to the creation of a very competent academic faculty. Professor Bhattacharya was the director of Indian Institute of Astrophysics from 1982 to 1990 and was the emeritus professor of IIA till 1997. He He was a fellow of Indian Academy of Science and INSA. He became the president of Astronomical Society of India in 1986. He was bestowed with many such honors and awards during his illustrious career. He passed away on 4th of June 2012. Following his demise, his admirers and students decided to start this memorial lecture series in physics department of this college under the guidance of the Department of Physics and former Students Association of Physics. And this is the 10th lecture of the series, and we all feel very proud and happy that you have been able to continue this program very smoothly without a break. There is no time and scope for me in this very brief welcome address to dwell in further details on different scientific aspects of, and I hope our secretary will mention some of these works in his address. As I have already mentioned, in today's lecture will be delivered by Professor Arnab Bhattacharya, and as it reflects from his talk on the subject, mask unmasked, ... it is of paramount importance to all of us in this present pandemic scenario, and all of us are waiting eagerly to hear from him. And I really do not want to step further into the time schedule and delay the process. We are thankful to Arnab to give us his time for this lecture in spite of his very busy schedule. I will request Dr. Pradipta Mondal to formally introduce the speaker to the audience. Let me end my address with deep thanks to all concerned, the authorities of the college, head of the Department of Physics and different staff members, my fellow colleagues in the Physics Alumni Association for their guidance, support and efforts to make this program a success for so many years. Thank you all. I will now hand over the mic to Joyita.
Thank you, sir. Thank you, sir. I request, now the technical session will be conducted by Dr. Pradipta Kumar Mondal, Secretary, former Students Association of Physics, Scottish Church College. I request Pradipta to start this technical session.
Am I audible?
Yes.
Okay. From the former Students Association, I, Pradipta Kumar Mondal, welcome you all. Every year, we conduct Professor J.C. Bhattacharya Memorial Lecture, and we try to make this subject of this lecture out of the physics. Professor J.C. Bhattacharya was our alumni. He awarded his BSc degree in 1949 from Calcutta University. After graduation, he carried out his career in radio physics and electronics in Calcutta University. And there he actually shifted to the experimental astrophysics. During his research career, he performed several path-breaking experiments in astrophysics. Out of them, he is well known for his discovery of the Jupiter satellite Ganymede and the ring around Uranus. Another revolutionary discovery was to find the rings of the Saturn and 6 main asteroid belts, one of which named Bhattacharya after him. After that, later in his life, he became the director of Indian Institute of Astrophysics from 1982 to 1990. He was fellow of Indian Academy of Science and INSA. He became the president of the Astronomical Society of India in 1986. The present-day structure of the Indian Institute of Astrophysics, IIA, owes much to Dr. Bhattacharya. He died on 4th June 2012. After his death, our then head of the department, Dr. Arup Roy, proposed to start a memorial lecture after for his name, and he also funded for that. And first J.C. Bhattacharya lecture was conducted September 2012. Today it is 10th. Now let me introduce introduce today's speaker, Dr. Bhattacharya, Dr. Arnab Bhattacharya. Dr. Bhattacharya is a scientist, thinker, and science communicator at the TIFR, Mumbai, where he leads a research group in semiconductor optoelectronics. He is also the center director of TIFR's Homi Bhaba Center for Science Education. He obtained his BTech degree from IIT Bombay. He did his MS and PhD from University of Wisconsin Medicine. He did postdoc at Ferdinand Brown Institute in Bali. After that, he joined TIFR. Beyond the research lab, Dr. Bhattacharya is passionate about science outreach and enjoys talking about science, demonstrating science experiments. To all audience, particularly school and college students. He pioneered Chai and Why, Mumbai's popular science cafe. He is presently the chair of science, popularization and public outreach at TIFR. He received the 2010 Homi Bhaba Award in Science Education. Again, 2012, Chevening Rolls-Royce Fellowship also awarded to him. Innovation Leadership in 2007 by INSA Indira Gandhi Prize also awarded for popularization of science. Other than these, he had interest in several other things, music, cooking, hiking, etc. Now, I request Dr. Arnab Bhattacharya to start our today's lecture.
Thank you so much, Pradeep Tada. Thank you very much. Can you hear me? Am I audible? And can you pin my video maybe? And I will also try and see if I can share this screen. Okay, so can you see my screen?
Yes, it is coming.
Okay, great. The only problem is now I can't see the Google Meet window, but it's okay. We will assume that it's there. So please shout if something goes wrong. So thank you, Professor Mondal. Thank you, Professor Das, and Pradeep Tada especially for inviting me to give this lecture. It's a privilege and an honor, and I'll explain why in a bit. I'd also like to thank Dibba Shankar, who is a student in TIFR, one of your alumni, who actually told me about this and convinced me that I should do it. So before we get to the topic of masks, okay, I want to say that this is, and I didn't realize it, I actually did not realize it when I accepted the offer. This turns out to be a deeply personal memory, personal links both to Scottish Church College itself and to Professor JCB. I would not have been in science today if it was not for Scottish Church College, though I am not an alumnus of the college or have ever studied there. In the late 1970s, early 1980s, when I was a young child, we used to go to Kolkata every summer vacation, winter vacation. I am born and brought up in Mumbai. And we stayed with my uncle in very close to Scottish in Horituki Bagan Lane. And he eventually became he was in the chemistry department. He eventually became principal for a few years. I think it was in the 1980s, Oporish Bhattacharya. And he used to allow me to go to the lab. I was a wanted to always play with things. And I remember this, old chemistry lab where I used to go and play with things. And, I also remember in those days, some of the places there had a DC power supply and the fans were very different. So that's Scottish. And there was a lane behind the shortcut to go there, which, had a very nice name named after one of the older principals, I think, but it also had a Bengali name, which I cannot take over here. Anyway, and coming back to J.C. Bhattacharya. So he also happens to be a one-level removed uncle of ours. And whenever he came to Mumbai, he would stay with us. And from him, I have heard stories growing up of the ring system of Uranus and the occultation what was used. And then as I grew up, as I was in high school, I got more and more interested in astronomy. And I think the turning point was 1986 when Halley's Comet was there. And he had brought some very nice pictures from Kavalur, the observatory there. And when I decided that I wanted to do astronomy, I actually took some vacation classes in astronomy in 1998 to try and do astronomy. I had a talk with him again. Unfortunately, my career is such that I never landed up being an astronomer. I got into semiconductors and material science and everything else. But I think I'm still a pretty good amateur astronomer. I'm still on the ASI's outreach committee now. And by the way, I hope you know that recently in Kavalur, the 1.3 meter telescope that they have a big 2-point-something meter, the Vainu Bappu telescope. But the next telescope, the 1.3 meter telescope, is now called the JCBT. It's the J.C. Bhattacharya telescope. So it has been named after him. Okay, let's move on. So I am a storyteller. Okay, and today's story is going to be about something that, as has already been said, we know a lot about, which is masks. And I'm going to tell you the story of how I got into it. Why is a guy in semiconductor physics suddenly doing masks? Okay. So I'll tell you how COVID changed things and how I got into this. The experiments which we did with Tata Memorial Hospital. And then we did a lot more fun stuff. And if there's time, we can talk about ultraviolet light, since this is a physics audience. But the reason I chose this topic is because initially I was not sure what was the audience going to be like. I thought I should take a topic which is connects science and society. It connects science and society in a way where you can see the interdisciplinary nature of science. This is not something limited to physics or biology or engineering or anything of that sort. And it also highlights a very important aspect of science today, which is that science is a collaborative endeavor. It's something we do with people around the world. It's something we do, and this links that are formed have been quite amazing for me in the last year and a half. Okay, so I don't know how we're going to do question answers. I mean, I cannot actually see the live chat. So if there is a question on chat that's important, somebody please speak it out and I will try and take it right then. Otherwise, we'll do questions in the end. Is that okay?
I think you can finish up the lecture and then we will take up the questions.
Okay, all right.
Okay, so that questions will be, I just request all the people to put their questions in the chat box so that after the lecture, Arnab can see these questions and can answer. Is it okay?
Great. So I would like to thank a lot of people who have contributed to the stories behind this that we'll talk about. So there is Shankar Ghosh, who's been sort of my partner in crime, and my student Emroj, who is hopefully listening today. Emroj Hussain is, I think, the 2012 batch BSc Physics from Scottish as well. He was my student, just graduated last year, and he was stuck in Mumbai during the pandemic, and turned out to be lifesaver in a way that I had somebody to help me work with on masks. A lot of the work is done with Tata Memorial Hospital, and the doctors there are just amazing what they've been able to do in the middle of this pandemic. There's also an international consortium called the N95 Decon Consortium with whom I have worked, and so many people have sent us masks and help us to make things and all. And I've unfortunately had to be away from home during the pandemic, and I would really like to thank everybody at home as well. Okay, so let's start. Every culture through history has had masks, right? Whether it is for protection, whether it is for disguise, whether it is for performance, there have always been masks, and here is a selection of masks from history, right from almost 9,000 years ago till the present. Different cultures have had masks. And I said protection. Well, the first masks, if you look at the Inuit masks in northern North America, where there is a lot of snow and ice, to protect themselves from the reflection of the sun, they used masks. Even for pathogens, in the 17th century, when there was a plague, people had these weird bird-shaped masks in which they put some nice smelling things, because of course they didn't know what was causing it, but the plague doctor would come with this bird-like mask. And today, of course, the COVID warriors in the hospitals are in full attire with masks, and all of us are wearing either a mask or a N95 or a dupatta or something, but we have to cover ourselves. So there are so many types of masks: cloth masks, N95 masks, surgical masks. What is the difference between all of these? And of course, what's the physics? We'll come to that. Now, there are two basic types of masks. One is what is called an N95 mask, which looks either like this, or you have this kind of a mask. And the other masks are the surgical masks, the blue ones, which typically look something like this. Okay. And the idea is the surgical mask is something that the doctor wears. It prevents my own droplets to go on a patient when I'm, cutting him up or something. Okay. On the other hand, so this is meant to protect from large droplets. It's loose. By design, it is not sealed at the sides, so air leaks out from the sides. On the other hand, an N95 mask is designed to fit tightly here, and it is designed to filter out very small particles. Okay. Now, what is small? What is large? Physicists, we will worry about numbers. We'll come to it in a bit. But first, let's start at the very beginning, because I'm assuming that not everybody is a physicist over here. I want to keep it as general as possible. What does a mask do? A mask is filtering, and since N95s are in the stock, just remember, what is that N? It means it's not oil resistant. Okay, and 95 means that 95% of particles of 0.3 nanometer size and above. Okay, 300 nanometers, 0.3 microns, 300 nanometers. 95% of the particles at this size are filtered. Okay, that's the 95. Now, first, let's see what makes a good mask. Obviously, number one, filtration. It has to keep out whatever you don't want to breathe. But it should not make breathing difficult. See, if I take a stainless steel bati and I put it on my nose, that's 100% efficient. Nothing goes through a stainless steel bati. But you can't breathe through it. You'll suffocate. So there is always a compromise between filtration and breathability. The other thing is, it must fit. If the mask doesn't fit well, if there are leaks at the side or leaks near the nose, it's not filtering very well. Also, if a mask is not comfortable, and this is something which people forget, if it hurts your ears, if you have elastic bands which are going to hurt your ears, or if it's going to leak and if you're like me who wears glasses, the glasses get fogged up, you're not going to use that mask. So, it's not very useful then. So a good mask combines all of this. And filtration is something which we study from at least the 5th or the 6th standard. This is 6th standard CBSE book, where it says you can filter your chai through a strainer. You can, pick out stones from grain. And the same chapter has this very nice figure of somebody in a construction site filtering the sand by removing the big stones from it and getting finer sand. And this is basically what we have to do in a mask. So I have a mask. On one side, there are particles in the air. We'll worry about what those particles are. I don't want those particles coming in. I don't want to breathe them. So this means now we're going to get a little bit more into specifics. What sizes am I interested in? Now, remember, most of the typical pollutants, smoke particles, pollen, etc., they are like, 2 microns to 10 microns and above. Okay, that's why the pollution numbers you hear of PM 2.5 and PM 10, that's the number of these large pollutants that are there. Bacteria are also between somewhere like 0.3 microns to 10 microns. Viruses are much smaller. Viruses range between 20 nanometers to 300 nanometers. The SARS-CoV-2 virus is about 160 nanometers. And then of course you have fragments of all of these. So it depends on what you want to filter. But remember that it is very unlikely, it is very rare that a single viral particle is going to be in the air. Most likely the particle is coming from somebody who is coughing, breathing it out, etc. And this particle is in a droplet of saliva, which is much larger. So practically, it is important, even if you have something which can filter out most of the large particles. Yes, if you're in an environment where there is lots of viruses, in the hospital where you're working with a COVID patient, then maybe you do need this protection at 3.3 microns. But for most of us, as long as you can get the micron and larger particles filtered out, you're doing good. But first, let's understand. And now given that, so this is a bit because this is a physics audience, how do we, somebody who's got cold, cough, whatever, is coughing out particles, whether it is TB, COVID, it's all the same. How do these particles get produced? What is the size of these particles? Okay. Now, how are these droplets generated? What happens is our throat, there's a mucus lining. There is something that goes and triggers it. Could be a dust, could be something else. Okay. And the body doesn't like it. It's going to send a gust of air to try and remove that particle. This gust of air is also going to break down this film of mucus that is there and throw that out also as drops. Okay. And this is very basic physics of fluid instabilities. If you have a layer of a fluid, if you have a fast moving jet of air moving on this layer is going to get ripples, and eventually at a higher speed, you will build up a Kelvin-Helmholtz instability, breaking up this particle, this layer into small particles. Okay, and this is something you see in nature, you see it in clouds, you see it in if you look at the, recently there was this magnetic storm and of solar particles. When the solar wind interacts with the Earth's magnetic field, you also get these little loops and things being sent out. So the physics is a completely different length scale. The physics is the same, what is happening inside the throat and what is happening in the sky or in space, wherever else. Now, the droplets are of various sizes. So depending on whether you're talking, breathing through your nose, breathing through your mouth because you're exercising, coughing, you will have different sizes. And as you can see, coughing, the last one generates a lot of very small particles. Okay, so this is particle size, small particles, large particles. Coughing generates a lot of these very small particles because of the mechanism that I just showed you. Now, when you have a filter, okay, you also must think of what size particle can I filter. In an ideal world, if I have a gap, physicists love to think of things as everything is a sphere. So you think I can fit, a particle. So to first approximation, if I have a gap, particles of that size will go through. However, we have to be careful because in the real world, particles are not spherical. So here is a gap. Obviously, these small particles will go through. And a particle which is much larger, if it is a sphere, will get blocked by this. But suppose you had a particle which was asymmetric, which was thin and long. Depending on how that particle comes, so this one will go through. On the other hand, if it came like this, it wouldn't go through. So you have to worry about multiple length scales in the problem, right? Now, any particle that is going to come is sort of, there are fibers in your mask. It's going to come and hit it, get attached. Some of them will come, some of them will get removed. So you want to worry about at what rate are things sticking, at what rate are things getting detached from it, right? And there are various ways in which filtration happens. The simplest thing is, of course, if I have a fiber, so I have a mesh of fibers in the cloth or whatever I have, a particle comes. Luckily, if the particle, remember, is not, it's following the streamlines of the air. These are very small particles. By chance, it may hit it and it is stuck. So Kolkata, everybody likes football. It's like the goalkeeper has managed to stop the football being kicked. Direct interception. This is one way of doing it. However, there are other things as well. Remember, particles have a finite mass, and even though they are flowing, they cannot always bend at the same thing. They could get thrown out because of inertia. So inertia will help you also intercept some particles. They cannot follow the streamlines of the air around the fibers. So there's inertial filtration. There's also diffusion. This is like the famous drunk walk. There are particles which are diffusing, and diffusion will make sure that some more particles hit your fiber. Okay. Is this enough? Is this enough? Because of all this, effectively, though you have a small particle, because there is diffusion, there is inertial impaction and all that, the particle behaves as if it is much larger. So even if you have a gap like this, you might be able to stop small particles because they behave as if they are larger particles. So far, we have looked at this, but this is not enough, and I'll explain in a bit. The final mechanism that we need is electrostatics. We will add a charge. The charge attracts particles. On a dry day, you can comb your hair or take a comb and it will attract some small pieces of paper. So even remember, your particle is mostly in a droplet of saliva. Even if the particle, if it's charged anyway, it will get attracted. But even if it's not charged, as long as I can have an electric field somewhere, and a gradient of an electric field somewhere, I can trap these particles. Okay. And this is what is needed. Remember this chart I showed you? For the large sizes, if you have micron-sized particles, micron and above, simple filtration, the mechanical filtration is enough. However, when you go to very small particles, when you want to go to sub-micron, without electrostatics, it's near impossible. Let me explain. So an N95 mask, which is this, has actually many layers. Okay. Of course, there's an outer layer which is typically hydrophobic so that it doesn't get wet. But the main filtration is done by the middle layer, which is very fine particles which are charged. Now, in a cloth mask, if I had a simple cloth mask, there it is inertial filtration or mechanical filtration. The pore size determines the filtration efficiency. Now, if I want to make a mask such that you can filter very small particles, I can make the pore size very small. If I make the pore size smaller than 0.3 microns, 300 nanometers, it would be unbreathable. It would be unbreathable. It would be so difficult to breathe through it. Hence, what the N95 mask relies on is an intermediate layer of fibers with electrostatic charge. This charge attracts small particles, so I can have gaps which are large, but they still filter very small particles. And this is why reusing these masks is difficult, because if you wash it, etc., you remove the charge. Okay, this is just an example of a mask. This is actually a 3-layer surgical mask, which is the same construction of a N95. You can see this marker. Don't worry about the, just look at either the top row or the bottom row. Just look at the marker. The yellow marker is 200 microns. Okay, 200 microns. So the inner layer and the outer layer have fibers which have pretty large, very large gaps. Okay, this is like your standard cloth. The middle layer is very fine fibers, but even this, the gaps are not sub-micron. The gaps are in microns, but it still filters 0.3 nanometer 0.3 micron particles because of the electrostatic charge. Okay. And also remember, it's not just one layer of fibers in which something is getting trapped. It's actually, for that particle, it might be, the thing might be 0.5 millimeter thick. The layer of filtration layer is 0.5 millimeter. But in 3D with fibers, it's very dense fibers. It's a mesh. And for a particle to get through that and come out, it's difficult. It gets trapped. That's the logic. Now, getting back to numbers. One of the biggest reasons for confusion between these surgical masks and N95s, and also the reason that you get cheated, and there are lots of unscrupulous vendors, is because of the norms which say that a surgical mask is qualified by its bacterial filtration efficiency, which has to be 95% for 3 micron particles. On the other hand, an N95 has to have an efficiency of 95% for 0.3 micron particles. 10 times different. But many people will just do a test at 3 microns and say, 95% efficiency, N95. Okay, so this is a big thing. Okay, of course there's fit, right? If you have an N95 mask and you leave it like this, it's not doing anything at all. Okay, let's go back to this window. So now coming to the story, that's the physics background. So in last end of March, the lockdown is announced, and Mumbai becomes very quiet. I thought I will get some time to write some papers, etc. But one day I get a phone call from Tata Memorial Hospital saying that they are running out of N95 masks. They need to figure out some way to decontaminate and use it now, as soon as possible. Please do something, help us. Okay. Now, what can we do? I'm a physicist, I'm an engineer by training. I don't work with bacteria and viruses and all this, but we know that there is enough medical literature telling us how to kill the virus, how to zap it, how to make it inactivated. However, you must make sure whatever you do, whether it is gamma ray radiation, whether it is boiling it, autoclaving it, it should not damage the mask. The filtration efficiency should not change. And that is a physics problem. Now, a mask tester, if you wanted to buy a machine that tests the filtration efficiency of masks, that's 20 lakhs plus. There's a lockdown, difficult to get it. Even if you had 20 lakhs, you couldn't get it because the US was not exporting them anymore. Everybody wants these. So how do you measure filtration efficiency? So the idea is this, a simple way, as long as I can count the number of particles in a given volume of air, right? So I have some particles in the ambient, the air is dusty here. We will suck this air through a filter and measure how many particles are going through the mask with a particle counter. If I can count this, the efficiency of the mask is basically 1 minus whatever went through the mask divided by whatever was there. And luckily we found that thanks to this air quality, concerns, PM 2.5, PM 10, etc., there were a lot of places where they had pollution monitoring equipment. Pollution monitoring equipment use these small sensors which actually count particles. So we thought, can we repurpose them to make a mask tester? So initially, of course, we were trying experiments with, with a helium neon laser, trying to do some scattering, trying to see how we could do it. Eventually, we got one of these particle counters, this AQI sensor, and this, we were working at that time almost 24 hours a day. And within a few days, we actually had a prototype of a mask tester. Remember, this is made during the hard lockdown. This is made from just whatever was lying in the lab and at home. You can see this ball is stolen from children's toys. There's some blocks of wood put here. We don't have a mannequin on which we can put it on the face. We just use a ball and tie the mask around it. This is how it was made. But, this is the beginning. As they say in Hindi movies, picture abhi bhi baki hai. So lots of interesting details to come. So we had this, what is called the mask integrity test resource. You have to give it a cool name. You call it Mitra. And essentially you have a ball on which you can keep your mask. You suck the air with a pump through a flow meter and this little device, which is a particle counter. And this is how it looks. Actually, this is how it looks. This is the part of it. I can go through it later if you want in details. But we made this not for 20 lakhs, but for 20,000, for about 20,000. And we decided that this is something which, this was a pandemic. We had to get it out to as many people as possible. We said we're not going to license it or anything. We just put it out on GitHub, open source, anybody can use it. And again, Ambrose, your alumnus, our student, fantastic job in helping us do this along with the rest of the folks who were there. Now, once you have a mask tester, this is the beginning. This is the beginning to do, of course, a decontamination, which Tata Memorial wants us to do. But we also were able, so every mask so Tata Memorial is getting donations of masks. And as has been pointed out by Professor Das, there are lots of unscrupulous elements selling masks. So they got lots of fake masks. We unearthed a big racket. So it allows you to test masks. We could do some cool experiments. I might come to that if we have time, on electrostatics of masks. We helped lots of different groups around the country measure masks and measure materials. We applied for some startup grant and helped a startup make a company to do this. And we did some fun things, which I'll talk about later. But of course, remember that the whole idea was to decontaminate, to reuse a mask. Okay, so the idea is I want to zap these virus things, but I don't want to change the filtration efficiency. Now, again, just remember that there's a lot of hype, junk, whatever you call it, in the literature, in the press, popular press, WhatsApp University. N95 masks have always been designed for single use. Okay, obviously the company wants to make profit. Okay, and nobody, when there was no pandemic, there was no real use for this. People, it was designed mainly for not just for medical people, right? Also for people scraping walls and working in mines and all that. Okay, now there's a crisis, you want to decontaminate. Now, since this is a science audience, just remember decontamination means as long as I've got 99.9% of the germs out, I'm happy. What is called a 3-log reduction in pathogen count. It's not sterilization. Sterilization requires 5-log reduction, 99.999. Okay. Now, mostly in reuse, just remember that it's not the mask filtration as we have found. And all these masks which are here, you can see this guy's ear strap is there only on one side. Some other guy's nose clip comes out. It's not often the mask which is a limitation. If you take any mask and you wear it 10 times, you're very likely to break the nose clip. Okay. So now, people have shown a lot of things, have done a lot of work, especially my colleagues in this N95 decon group. I was also part of them. Alcohol. So, alcohol, sanitizer, rub your hands, 20 seconds, done. Wash your hands with soap and water, done. Unfortunately, all this removes the charge. If you remove the charge, efficiency is gone. Bleach, same problem. Also, you don't want any chlorine residue on your mask. Ethylene oxide, used a lot for sterilizing needles and all these syringes and all. Very risky. You don't want anything where you can breathe in. You don't want any residues. Gamma ray radiation kills the virus, but unfortunately, the gamma rays completely destroy the polymer structure, so it reduces the efficiency. Sunlight does not have enough UV to sort of do anything to the virus. There are processes that are available. There's hydrogen peroxide vapor, which is possible in the large scale industrial process. The easiest thing is time. The SARS-CoV-2 virus does not survive for more than 96 to 120 hours on any surface. So if you get what most of the people in Mumbai in the hospitals do, they have 5 masks. You use mask 1 on Monday. After you use it, you keep it outside in a well-ventilated place. Use mask 2 on Tuesday, etc., etc. After 6 days, you can use your mask 1 again, right? Not doing anything. Of course, heat is the one easy way to do it, and UVC. So I will, in the Indian context, heat was the easiest one. And I thought, let's use heat. That's the easiest thing to do because we want to do it quickly. We don't have 5 masks. We need a lot of masks. You could give everybody 5 masks, right? So I am a scientist, of course. So I start off by wanting to do proper experiments. I stuck temperature sensors on masks, measured the temperature profile of a small oven, did some experiments following what protocols we knew that 70 degrees should be enough. And then we had a lot of fun doing it. We tried with, the chai water boiler and lots of things. We had lots of fun. Anyway, now, does it work? Yes, we did experiments with N95 masks with different companies. They're around 95%, and you can subject them to 5 heat cycles. Nothing happens. Same thing for these surgical masks. You can do 5 heat cycles. Nothing happens. Of course, you get them in different qualities. Come to that later. And then one day, we took everything and went to Tata Memorial Hospital, where it's not 1 mask, but you have to scale up to 200 masks a day. 200 masks a day. This is like nowadays, maybe in a mall, you find these big cabinets where they store cold drinks and cold stuff and all the butter and cheese and all. Similar thing, hot cabinet, 70 degrees. Okay. Now you have to do something. Remember, at this point last year in April, May, we knew nothing about COVID. We didn't know anything about the virus. Everybody's paranoid, right? Once I have a mask, I assume that the outer surface is contaminated, right? Also the inner surface, this is somebody's mask. I don't want to touch it. So you want to have a method where, so remember that somebody had done such a method putting the mask in a box so that they could control temperature and humidity. But this requires you to put the mask out and put it in a box. Somebody has to touch the mask. Right? We wanted it to be something where even an unskilled operator can do it. So, Tata Memorial Hospital is a cancer hospital. Their chemotherapy department has lots of vomit bags. So we just use those. We ask the doctors to write their name on the bag, put your mask inside, just drop the mask in the bag, keep it open. So nobody touches the mask. The bag goes in the oven. You can see this oven loaded with bags and do it. And the other thing is you have to develop a protocol how everybody in the hospital is going to use it, detailed descriptions of exactly what it is to do. So, doing an experiment on 5 masks, but designing something which can be used in the real world 3 shifts a day, by somebody who is not a physicist or an engineer is something which was a big learning experience, a massive learning experience for me, and extremely satisfying. It was extremely satisfying. I mean, I've published probably 100 papers, but to see something you've made being used in a hospital 3 shifts a day, 10,000 masks gone through this process, more than 1,500 doctors, nurses, etc. used it. This is perhaps the first large hospital real-world demonstration of heat-based decontamination of these masks. But of course, Tata Memorial is one of the better hospitals in India. It's one of the better hospitals. Okay. By the way, I don't know how I'm doing on time because I tend to get carried away and speak. So if you want me to just wrap up, I can always jump and shut down things. If you're enjoying the stories, we go ahead. What if you don't have the resources that Tata Memorial has? What if you want to do it simply? So what if you don't have electricity? One of the easiest things to make is hot water. I can burn some wood, leaves, paper, whatever, I can make hot water. And what you can do is you can take 2 dishes in your kitchen. So we wanted to see, can we do it in the kitchen? So you don't put the mask in water. You put hot water in a big bowl. You put a smaller bowl inside it, put your mask inside it, cover it for some time. Does this work? So again, this is in collaboration with Manu Prakash's group. They were trying to do it. So we also did it in our kitchen. In India, again, I'm doing science. So I've connected temperature sensors and all on my masks. And then we decided that, hey, we can do one step better. Why don't we do one mask at a time? So at least, I don't know in Kolkata, but in Mumbai, almost every household has these idli cookers where, you have these different, you put it in a pressure cooker. They have trays with little depressions where you put the atta for making idlis. And we can make this so that we can do stacks of masks. So by the way, if you had asked me, 1 year ago that, can you get a picture of an idli cooker in your kitchen inside a scientific journal? I would have said, are you joking? But this picture is actually this is published work. Okay. This is published in +1. So, of course, we did there's a lot of data along with it as well. So again, as a scientist, I have measured temperature and humidity profiles, measured the efficiency, and, we can do this at home in a very simple manner. You can decontaminate masks without any impact on the efficiency. But there's more fun we can do. So I have friends, thanks to my outreach in all parts. I was working with Amoj, Amoj is a IISc graduate who is now working with the tribal community in Nandurbar in Maharashtra, making solar concentrators. So we thought, can we use solar energy? And yes, we can. Of course, at that time, it was already June where the monsoon was coming. So he moved to Ahmedabad where it was still sunny. And we can use both the typical the box cookers or mirror furnaces. You have to be very careful. You don't want to go beyond 10x concentration. You want to just decontaminate masks, not incinerate masks. We can also make solar incinerators for masks, very easy. We used to. He did these very nice experiments. You measure. This is typically you got to take care that it doesn't go above 90 degrees. You don't want to melt the plastics. So these are all polypropylene fibers, the thing in the mask. And sometimes we saw very interesting things. So typically the temperature in the day goes up, stays there, and then comes down. And 21st June, the very interesting data. So there is this very big dip. And this was the day, we were wondering what it is. And this was the day there was a solar eclipse, partial solar eclipse that day. So it's very nice. I've done a lot of other interesting things. There was a very large, so these surgical masks, can you wash them? Why do we have to use a new one? Can you wash them? What happens to their filtration efficiency? Yes, the charge will go, but sometimes they don't have charge. Does it matter? So we actually, and you get them in all kinds of qualities. There are masks which are, 3 rupees. There are masks which are 7 rupees. There are masks which are 10 rupees. What's the difference? And of course, the difference is charge. Some of the best masks are actually as good as N95 in the material. So we actually, I was working with a group of doctors in Bangladesh, with them, they wanted to do an experiment, very large RCT with 350,000 people in different villages on mask usage, comparing cloth and surgical masks and washing them. So all the washing studies, actually the data is from my lab. We actually did a lot of washing studies in the lab, washing them with the cheapest way possible with a detergent bar, wash it, dry it, measure the efficiency. So we did a lot of work. And the summary is, you can wash it 5 times, 3 times, no problem. Nothing much happens to the efficiency. Initially it decreases a bit, but then it stays constant. And even if you take one of these masks, which is really good, which is like 95% when new, you will go down to about 80%, but 80% is still better than a normal cloth mask. So, then of course we did some science. And remember, all this while I have told you that the main thing that makes an N95 and N95 is electrostatics. And the problem is that the mask, once you wash the mask, your electrostatic charge goes away. Can you put it back? And this is work which is, again, Emroj is the first author on this, which we did last year on trying to electrostatically recharge a mask. You need to put, of course, you put it, the simplest way to recharge, you want a high field, you put it between a capacitor. A capacitor is simply 2 metal plates in which you sandwich your mask to a high voltage power supply. Now, in the middle of a lockdown, how do you get a high voltage power supply? Simple, cheap. Well, you take one of these mosquito bats, the thing for mosquito bats. You take them, they have a simple high voltage supply, you can connect it. And so what happens is when new, the mask is about 95% efficient. You wash it, it's down to 75 since the charge has gone. You keep it here and charge it, recharge it. After a while, you can get back to your 95%. So after this, we thought, can we make a smart mask? Something like this is continually charged. So we tried to make a mask which was a holder with a cartridge where you could put in a filter element, which had a mesh on both sides, where you could apply a voltage and charge it. Of course, this is just a prototype and a concept, but it was been fun to see all the different aspects of science that you could do and physics that you could do with this. So we'll stop here. I can talk a little bit more on practical issues. I'm sure there are going to be lots of questions. So we built a compact, low-cost filtration efficiency setup to test these masks, and you find that there are tons and tons and tons of masks. Not all of them are the same quality. Not all of them are thing. It's not just the mask material. It's also the fit and straps. And you will see masks where the strap comes off. And we also found, I've put the link in the chat actually, there is a huge proliferation of poor quality masks in the market, some of which is not deliberate and unfortunate because many of the labs, at least last year, did not have facilities to test the mask. The government did not have a good scalable system for BIS certification. But a lot of it is also, I would think, deliberate because this is an easy way to make money. Just sell a mask, everybody is buying a mask. For the N95 masks, you can decontaminate and use them. And it's actually it's not very easy. We did some really wonderful work with the doctors at Tata Memorial. And also it was fun exploring, the solar and hot water and low-cost methods for doing this. And I would say even these surgical masks, you can at least wash them 5-6 times, no problem. And for me, I think the reason to do it is not so much physics, but environment. This is all melt-blown or spun-bond polypropylene. These are all non-biodegradable fibers. Just think, if all of us are going to throw one of these masks out every day, how much of medical waste are we going to generate? At least if we can wash them and reuse them a few times, it's much better. And just for that aspect, I think reuse of masks is something we should look at. And in the last year and a half now, I've had a lot of fun learning new things. I am trained as a semiconductor person. I'm trained as a material scientist. I didn't know a word of masks when I started. I had a lot of fun learning about masks, and I hope I could share some of this excitement with you. I will end with a much more interesting picture, which reminds me of Kolkata. It probably is Kolkata looking at the trams. Is that in India, we can do a lot of research on making the best mask or how to recycle masks. But if people do not wear a mask that covers their nose and mouth, there is no point. We can't blame anybody else then. On that note, thank you a lot. Thanks again for this wonderful opportunity, and I'm happy to take questions.
Thank you, sir, for such exciting lecture. I think today's lecture will help us to increase our knowledge about different kind of mask, which is very necessary for today's life. We also learned that how a mask could be used in most efficient way. It makes me happy that my student Ambrose is working with you. Thank you again. Now, I request my colleague, Dr. Joydeep Mitra, to conduct the question answer session.
Okay, so as already have said, if you have any questions whatsoever, you can write those questions in your chat box so that we can see those questions.
Jaideep, may I
Yes,
ask you
yes.
a simple question?
Sure. You can go ahead. Yes, go ahead.
Professor Bhattacharya, this is the question regarding the charging of N95 mask. You applied a high voltage supply, a simple circuit. So charging like a capacitor in case of a DC source.
Absolutely,
So,
it is a DC source and a capacitor.
Yes. So may I request you to know the magnitude of the DC voltage applied?
2000 volts, I think. Ambrose, are you around on this call? I don't know if Ambrose is in YouTube or in Google Meet. I think it's 2000 volts. It's a standard.
Not so much the voltage, Arnab. I think
2000 volts. It's what you get from the,
It's not just the voltage. The electric field is what matters.
Correct.
So
Correct.
voltage as well as the gap between the plates.
So basically, two
But,
metal plates and the gap is just a folded masks gap.
Okay, so because Professor Sense, because the area of that N95 mask is almost nearly same, so in that case, voltage will also do the same same thing, I think.
I mean, the field is, if you have large enough metal plates, the field is uniform over the mask.
2000 volt. Okay.
2000 volts. Yeah.
Okay. Thank you, sir. Thank you.
Okay, sir. There is a question on the chat box by Triyash Mukherjee. You can see it. Sir, is there any way that we can identify which masks are fake and which are not?
Well, for N95, very difficult. But I can. So first thing is, just remember. Let's look at the more common masks, the surgical masks. Okay. Just remember that any good mask, and even if you're stitching your own mask with cloth, 3 layers at least, 3 layers. Okay. I'm gonna. This is a cheap mask. This is 2 rupees mask. I'll tear it. It has basically, you can probably see the green and the white. This had only 2 layers. There's nothing in the middle. If you take a good quality mask, this is one of the better masks from a branded place. I will now damage this. I'm going to cut this mask right here. Okay, so I have cut it. I'll rip it. Now you will see that there are 3 layers in this. There is 1, 2, and 3. And this actually has, so that the blue layer is outside, the white layer is inside, and in the middle, this is your layer of melt-blown polypropylene, which is actually doing the heavy-duty filtration. Okay, so first thing, ensure you have a 3-layer mask, not a 2-layer mask. If you're making your own masks, if you want to stitch your masks with an old Genji is fantastic, a t-shirt material, hosiery material, very good, except given that, I mean, it's for overall use, not for 0.3 microns. Just make sure that you don't keep the weave in the same direction for all the layers. So if you have this layer this way, the fibers are going this way, put the middle layer at 45 degrees and the next layer something, that way you increase the chance of interception. Okay. Now, one thing you can do is, and I don't know if Professor Das is still around, is look at any packaging the mask comes in very carefully. So here is an example of a, so if it does not have a ISI or a BIS number on it, if it has things like, these are like the warning signs. It says CE, okay, CE. CE has nothing to do with masks. it lists a lot of these ISO certifications. It's got nothing to do with masks. It lists is like tested by Citra. I don't know if you can read this. It says tested by Citra. Citra has said, it's the South Indian Textile Research Association who tests fabrics. They don't test masks. They've written that people should not use their thing on mask labeling. So there are sometimes you can look at it. If the advertising sounds like this is a great mask, it probably isn't. So I can't give names of individual vendors or something. There are only two NIOSH. So N95 is actually a US designation. There are only two vendors who are N95 classified in India, Venus and Magnum. But there are lots of fake Venuses and Magnum as well. I mean, Venus on its site tells you how to identify a fake Venus mask. So, this BIS, Abhishank is asking, what is BIS? Bureau of Indian Standards. Bureau of Indian Standards has laid down standards for various masks. IS 9432 or something. I don't remember it off my head right now, but a mask has to do this. Okay. Now, Shogoto has a question on the valve of an N95 mask. Fantastic. I don't know if there are other questions related to the earlier one, but I would love to take that question because this is something which I worked very hard, wrote lots of letters to get valves banned. Just put the questions. I'm just going to see if I have a valve mask lying here. I have literally thousands of masks over here. And yes, here we go. Okay. All right. So a valved mask. Let's open one of these. A valved mask. Okay, of course we have to tape the valve up, so we've taped it, but let me remove it. So you have a lot of masks with valves like these. These are the most dangerous things on the planet, right? Do not use them. These masks were not meant for medical use at all. They are meant for people who are working on scraping walls, working in mines and dusty environments, to make it easy to breathe out. This thing has a little rubber gasket. Let me see if I should have a lot of these here. Okay, I can. This has a little rubber gasket inside it, which will seal when you breathe in, but it opens when you breathe out. So on the way out, there is zero resistance to breathing out, which means if you have any, if you are the COVID patient, all your pathogens are going to go outside. So this is not meant for medical use at all. And in Indian circumstances, in the humidity that we have here, the dust load that we have, you wear this for an hour, one dust particle will definitely stick to the rubber gasket inside. Once it sticks to the rubber gasket, the rubber gasket will not seal, and it's not going to be a good mask even on the way in. So this is very dangerous. Many of us wrote lots of letters to the government because initially this was approved by the government and we got them to change it. The best thing to do if you have something like this is take the valve out and just stick some tape over it. This is a good mask. It's been taped from both sides, and you lose this much of area, but that's fine. Okay, now there are more. Okay, great. Fantastic. Emroj Hussain, my student who worked on this, also a Scottish student, is on the call, is on this thing, and is actually giving the answers to your voltage questions on the chat. Now,
yes. Emroj has already wrote this about 2000 volts.
I am taking the opportunity to thank Imroj, my student.
Yes.
Small world, no?
Yeah.
Small world. Okay, so
you have a question from Shamadrita. You have a question from Shamadrita.
Yes, on double masking.
Yes, on double masking.
Yes, double masking is is something which is actually very strongly recommended. So I will often use a surgical mask. And what is the problem with a surgical mask? This one doesn't have a nose clip, it's fallen off, but normally you'll have a nose clip out here, but by design, a surgical mask is loose at the sides, okay? Because the air is supposed to just go out from the backside. Now, which means if I'm breathing heavily, I will get some air leaking in. So then I can take a cloth mask. I can take a cloth mask, and this is a cloth mask which has some cloth. This is actually a mask which I've got designed in Bangladesh actually with my collaborators. It's called the Shurokha mask. If you can see this, the Shurokha mask. It's got an extra layer of cloth at the side. So when I put this mask on top and tie it, it sort of covers the sides as well. Now, one thing. Nothing. How do you make out a fake mask? Nothing with a ear strap is an N95 mask. Okay. Remember, if you want to have a good seal, you need some amount of force, right? The pinna, the ear, you can't take, you need almost 10 Newton force, which your ear will not like. It'll hurt. A good mask always has straps which you can tie behind your skull. Your skull is nice and hard. You can tie it behind your head and tie it tightly. Okay, so that's also something to be remembered, that a good mask is a mask which you tie behind your head, not on your ears.
I think there is a question from Dibba Shankar.
Dibba Shankar is asking about the rechargeable mask concept. Do you think it is mass producible? If yes, why is it not in the market till date? Well, Dibba Shankar, it is. Remember that what is in the market is not decided by science, technology, engineering. It's decided by economics. Correct? Even for a very good mask like this, the Venus's, the proper N95 mask, this thing sells. I mean, in the middle of the pandemic, it went crazy. But this thing, the MRP now is like 20 rupees. Okay. These masks are made on automated machines. They can make, 100,000 or a few 100,000 a day. The cost price for making it is probably 4 rupees, 5 rupees. The cost price for making some of these cheaper masks, the ones which you find on the roadside, as you said, is probably even less. The cost price for making the surgical masks, which you can make 500,000 if you're in a thing, is also just a few rupees. It is just not cost effective to make a mask which is rechargeable. It's just not cost effective. That's the reason. Okay, Emroj has answered to it. Shuvayu. Okay, Shuvayu is asking, is there a difference between N95 and KN95? Very good question. N95 is a US designator. It is 95% efficient at 0.3 microns. KN95 is a Chinese mask. It's a Chinese designator. So French have KF94, Koreans have KF94. In Europe, it is FFS2 or something. So every country has its own regulations and its standards. KN95 is Chinese. These are all KN95 masks. KN95s are allowed. This says N95. Some of you might say KN95 actually. This one, for example, says KN95. I don't know if it is going to be visible in this color. But KN95s are allowed to have ear loops. The Chinese thing allows ear loops. The decon process for them is identical because the material of the mask is identical. And does the filtration efficiency remain the same for breathing in and breathing out? Really not too many studies on this. But effectively, I think that there are not much difference except that people have done studies. Remember, when you breathe out, you're breathing out humid air, and humidity will eventually degrade your efficiency. So if you ask what happens after 8 hours of continuously wearing a mask, I'm sure the efficiency is lesser, but I don't think there are any studies. Okay, now there are hands raised by a few people.
You have a question from Shumon Maji. I think that's interesting. The last one. What we should
Shumon
use
Maji, okay, masks for rural areas, for all of us, rural, urban, everything, a cloth mask is fine. For most of us, a cloth mask is fine unless you are a doctor who's going to be handling a COVID patient at close range. You are in a place which has 500 people around you. Don't go to a place with 500 people around you is my thing. Don't necessarily go to a movie theater. I mean, I would not go. Unless you're in something like that, a normal 3-layer at least cloth mask is sufficient for all of us. It will protect you from the big droplets at least. Okay, and it's washable and whatever else. It will be, a cloth mask has probably 90% efficiency for the larger particles, and even at 0.3 microns is not zero. It's probably still about 30% or 25% or something like that. So it's not going to be zero. And yeah, so I would just say a normal cloth mask is fine. You can also use, I mean, if 3-4 rupees is affordable, then these too many masks here. These surgical masks are also a good thing, but I think if it's a surgical mask, either it had better have a nose clip and be good. Otherwise, it's best to wear something that can, if your fit is good, I think that's more important. I worry about leakage from the side. Okay, Rohit, what is the difference in N95 and F99? I don't know what an F99 mask is. I assume it filters 99% of something, but I have no idea what. So that is it. Upendranath Nunde, I have 20 masks with me. Yeah, I have more than 20 here. Which mask do I use? I use a surgical mask. Oops, I have cut it up now. I use normally a surgical mask, and on top of it, I use a cloth mask. I use a cloth mask to just tie it behind. So I normally use this. That's what I normally use.
Okay, I think this is the last question from Preetha.
Okay, Preetha says, if we want to decon a mask through heating at home, how much time do we need to get it done? So 70 degrees, half an hour is what you need. And what I will do is, let me just see if I can paste a link. I'll just paste a link. It's open source, so you can find it. Basically, what you do is, if you really want to decon safely at home, if you have hot water, you can boil some hot water, put it in a big dish, put a smaller dish inside, cover both, keep your mask inside for half an hour. We've shown that it remains above, and put a cloth around the outer vessel. We've shown that it will remain above 70 degrees for half an hour. I will put the link in the, let me just find it and put the link. I'll have to probably search for it. Oh, no, I know it's in my PowerPoint. I can get it from there. So yeah, I mean, somebody can keep asking a question I can hear. Yeah, I found it. Control C. Okay. So that link has everything on how to decontaminate masks at home, if you want it. And the particles of what size get filtered out when we breathe out? So the N95 is filtering out mostly particles above 0.3 microns, 0.3 micron and above, right? But of course, the 1 micron obviously the efficiency is much larger. It's probably 99% or 100, almost 100% at 1 micron or 5 microns or 10 microns. So Anupam, can you explain okay, so suppose this is a fiber. Okay, this is a fiber. Particle comes and hits directly. That's mechanical interception. Now, what happens if remember the particle is flowing on a streamline? Suppose the particle is flowing on a streamline, but it can't do the streamline. It's like a car which is skidding off the road at high speed. It just goes and hits this. That's the inertial method. The inertia didn't allow it to go on the thing. And you can have diffusion. So the particle is small, but it's sort of moving around everywhere and comes and somehow hits the fiber. So these are the sort of mechanical methods that are there.
Okay, so we have I think, all the yes.
I'm taking just 1 minute. Sir, Professor Kaveri Chatterjee, she is a senior professor of our English department of our college. She was present in this lecture.
Okay.
And she is overwhelmed with the lecture presented by you. So she has given you the very thank, many thanks to you.
Thank you, Professor Kaveri.
And if I can say, I think people have many more questions maybe. So if can we share your email ID or something that they can mail you if it is possible?
I just put my email in the chat. You can definitely get my
email. So all the people who are listening, if you have many more questions, you can directly mail to Professor Bhattacharya, and you will get it answered. So
just interrupting at this point. I think it will be better for this to you. You collect them together and send one mail to Arnab. Okay.
Okay. That will be absolutely.
Individual 40 mails will be going to him. He will be busy with his work.
Okay, sir. I'll do it.
Maybe some mail will be missed.
Okay.
It is better that you advise every one of them to write to you. You collect them together, give them a specific time, say within 3 days or 4 days. Then you send it to Arnab. That will be the collected one.
Good suggestion.
Okay.
Yeah, that's a very good idea.
Very good.
Okay. I'll do it. So you just send your questions to me, my email ID, and I'll send it to you.
Yeah.
Okay. Yeah. Thank you. So Pavitra, you can take over.
Yes. Okay. Once again, thank you, sir, for enlightening our audience. And we learned much, whatever we don't know previously. Thank you for again. And now we are going to close our session. And before that, I must thankful to my college authorities, my colleagues, all the audience for being with us. My special thanks to my student Deeposam to introduce you with us. Thank you, sir. We will meet again. And thank you, all of our audience.
Thank you very much. Thank you. I hope I can come to Kolkata sometime and actually speak to the students and everyone there in person. And thank you for enabling me to pay my respects to Professor J.C. Bhattacharya through this lecture. It has indeed been an honor and privilege to be at this forum. So from my side, thank you very much.
Thank you, sir.
প্রদীপ্ত প্রিন্সিপাল ম্যাম আছেন? প্রিন্সিপাল ম্যাম আছেন তো? প্রিন্সিপাল ম্যামকে বলো থ্যাংক ইউ দিয়েছো তো?
হ্যাঁ, খুবই আমাদের খুব ভালো লেগেছে এবং পরে যদি সত্যি এটা একটা পপুলার লেকচার হিসেবে যদি আমরা আরো বেশি অডিয়েন্সের কাছে আপনি বলতে পারেন, আমার বারবার মনে হচ্ছিল শুনতে। হ্যাঁ, তো নাথিং লাইক দ্যাট, ওটা আমরা চেষ্টা করব যদি
নিশ্চয়ই মানে এইটা ইনফ্যাক্ট এই টকের অন্য ভার্সনস হয়তো ইউটিউবে অলরেডি আছে, জানি না, কিন্তু মানে আই এম অলওয়েজ উইলিং টু গিভ আ টক এনি টাইম, not just on masks. I can talk on lots of other things as well. I mean, masks is actually not my core area of work. It just last 1.5 বছর এখন করতে হয়েছিল বলে করেছিলাম, but it was really nice. I enjoyed it.
Thank you very much.
Thank you.
Thank you, sir. Thank you, madam. Thank you.
I think we can end.
And we are going to end. Thank you.
Okay. Thanks, everybody.
Thank you.